Hi friends, welcome to follow up. Let's have a look at problem 161, one edit distance. In this video, we're going to explain a linear solution based on linear scan. So this problem actually is closely related to problem 72, edit distance, which can be solved using dynamic programming. So here, for this problem, we just need to use linear scan actually. So let's first roughly look at the problem statement. So we are given two strings s and t. We want to check if they are both one edit distance apart. So here, a string s is said to be one distance apart from a string t if we can either insert exactly one character into s to get t, or delete exactly one character from s to get t, or replace exactly one character of s with a different character to get t. So these three operations actually are in correspondence with the operations in problem 72. So here are two examples which are easy to digest. For example, the first one, so we can delete the character c in t, right? Or we can insert c in s, so we get true. And the second example, because they are identical, therefore they are not one distance edit distance apart, so we return false. So the difference of this problem from problem 72 lies in the problem size. So here s and t can be as long as 10 to the power 4, right? And this actually basically tells us that we cannot use square or m by n term complexity algorithm. Here m and n are the length of s and t. So another one is that s and t consist of lowercase English letters, uppercase letters, and digits. So that's actually not that essential for the algorithm itself. So with that said, we are ready to do the analysis. So for this problem, first, logically we can borrow the code for problem 72. So this is actually the code for problem 72. But what we want to return is that if the edit distance is 1. So this is what we want to check. So this logic is correct, and however, so if you use this code, it will get time exceeded a problem. So here, actually, because of the specification of one edit distance, this problem is actually simplified, right? So essentially, we have two cases. Either s and t have equal length, like here, right? So you spot one character, they're different. Then beside this, the position here, then we have a, b, e, f, g, a, b, e, f, g. So this is one case. Another case is they differ by 1. For example, we have a, b, e, f, g, and then we have a, b, y, e, f, g. If we delete this y in the second one, so we get the same thing. So another case is that if the length of the two strings differ by more than 1, so we just directly return false. That's actually very easy. So in this case, we also need to return true because we can delete a, right, to get the same empty string. So with that said, we are ready to translate these observations or cases into code format. So this is very simple. Without loss of generality, so we can assume the length of s is less than the length of t, right? If not, so we can do some treatment. So if m is greater than n, so we can swap m and n. Similarly, we need to swap s and t, right? So this way, we will see that m is less than or equal to n, right? So first, I want to check an edge case. If n minus m is greater than 1, so this corresponding to the case here. If the lengths differ by more than 1, we just return false. So now let's look at the more general case. So we first see if we can find a position which corresponds to different characters in the two strings. So we just need to scan or loop over the short length, right? So if si does not equal to tj, so in this case we located the index, right? So then we check two cases. If the two strings have the same length, so like here, right? So we slot the index 2, so x and y are different. Then we want to make sure the remaining part are the same. So what we want to return is nothing but si plus 1 for moving forward equals t I plus 1. This is one case. Another case is that m and n, they differ by 1. So in this case, we're going to return, we need to include this character from s. Well, we ignore the character in t, so we want to return this. So this actually assumes we can locate a position which corresponds to different characters in the two strings. However, it's possible that after we traverse the whole thing, and so we still didn't find something different. Let me give you an example. For example, in this case, so we have A, B, C, then we have A, B, C, D, right? So after you traverse over this first one, so you still do not get a different one. But in this case, we just need to return m plus 1 equals n or not, right? So this actually finishes the coding part for this problem. So before we make any comments, let's first do a test. So so here is I. Yeah, it passes one example. Now let's look at the generic case. It passes all the cases. So this solution is O of C. You can see O of M or O of N of C. O of the larger one. Let's see. So anyway, this is a linear time complexity solution. So let me make a comment. So for the edit distance problem, there are several problems in leetcode. Actually, this kind of problem is some fundamental concept or problems in information retrieval or natural language processing. So it's actually good to digest and make a genuine understanding. So with that said, I guess that's about it for this problem. Thank you.